Okay, look up. Here it goes. So, I'm going to solve it by graphing. Here it goes. So, by looking at this, I have two equations. One of them is already solved for y, and this form is called what? Y equals mx plus b, also known as slope-intercept form. Slope because the first part, or the coefficient of x, is the slope, and the plus b is known as the intercept or the y-intercept. That's why when we have an equation like this, we know that the constant, this one, is our y-intercept. What does that mean? We look at the y-axis, look for that point, which is -2, plot our point, and that's where my y-intercept is at. Are we there so far? Yes. From there, what else do I need to plot points? I need my slope. My slope is the coefficient here. I need to write it in fraction form. Why? Because the denominator is what tells me to always go to the right. Right? Right. Therefore, the numerator always tells me to go either up or down. Negative is if I'm going down, or positive if I'm going up. So here it tells me to go down 2 steps, one to the right, and I'm going to plot a point. To plot more points, now starting from this one, I use the slope again. 2 down and 1 to the right. 1, 2, 1 to the right. I'm going to graph my line, stretch it as much as you can. There it is. The second equation. Jocelyn. Make your own. All right. So, look up, please. Number 2. To graph the second equation, we can set it in slope-intercept form, can't we? Yes. Or we can use a different method of graphing, which is what we call cover-up. I'm going to cover up the x value. What do we see? Y equals 8. So I look at that point on the y-axis. 8 is right there, and I plot my point. Now I cover up my y variable. And what do I see? 2x equals -8. I solve for the x. And that's my x-intercept, which is -4. Where's x -4? X -4 is right there. I graph my line going through those 2 points. There it is. Did I graph both lines? Yes. This is the first method of solving systems, which is called solving systems by graphing. I did that. But I still haven't solved it because I still don't have my solution until I identify it. What is the solution to the system where both lines what? Intersect. So they intersect at about right here. Does everybody see that? Is that -2? No. Is it -3? No, it's about halfway, so the x value is -2.5. Comma, give me a second. What is my y value? 3. Now, some of you maybe did not get it exactly at 2.5 because of your scaling, but if you got close, I'll probably give you credit. Yeah, that's fine, because I know that you don't have yeah.
Are we gonna get a graph?
Yeah, I'm gonna give you a graph. So, are we okay with the first method? Yes. Okay. Yeah.
Wouldn't it be -y to 8, so then y would equal -8? Or
Let's see.
Just ignore the subtraction?
Let's see. It's.
Oh, the plus.
It's a plus, yeah.
Like a minus.
Okay. So let's go with the second method. So the first method was graphing. Second method, let's look at it. The second method is known as what? Substitution. Tell your neighbor why it's called substitution or substitution.
Because you substitute the variable.
All right. So substitution because we substitute one equation into the second, right? So do we have one of the equations already solved for one of the variables? Yes. This one solved for y. What is y? -2x minus 2. So on the second equation, instead of writing y, what am I going to write? Negative 2x minus 2. So I write negative 2x minus 2 instead of y. I bring down the negative 2x. I bring down the plus, the equal, and the 8. Positive times the negative is still a negative, right? So, negative 2x and negative 2x, that's negative 4x minus 2 equals 8, plus 2 plus 2, negative 4x equals 10, divide by negative 4, x equals negative 2.5. Did I get that over here? Yes. From there, I need a y value. Do I have any of these already solved for y? Yeah, this one. So I'm going to grab this one, and I'm going to write y equals negative 2x minus 2, but instead of x, I'm going to substitute negative 2.5. So I bring down the y, the equals negative 2 times that minus 2. Y equals negative 2 times 2, negative 2.5, that's 5 minus 2. Y equals 3. So my solution is negative 2.53. Is that the same as this? Yes.
So if we do the graph first and then the substitution, are you still going to need to check, or?
No.
Okay. Oh.
For tomorrow, you don't have to check because you're going to do 3 different methods, and the checking part will be that you need to get the same answer on all 3. Is that correct? Yes. How are we doing? Yes? Okay, set that aside. Get a blank sheet of paper out, please. Title your notes, Elimination Method, please. Elimination Method. Thank you. Okay? Not right now. Okay. So let's recap really quick before we get started with our notes. You do need a Ferrer model. Look up. So, let's see. We are still on solving systems of linear equations. So the first method we already saw right now with the warm-up, we covered, and it was graphing. Do we know how to do that? Yes. Second method is substitution. Do we know how to do that? Yes. Today we're going to cover a method called elimination, also known as combination, also known as addition. All 3 are the same method. Tell your neighbor what I just said.
All 3 are the same method.
Elimination, combination, and addition, it's the same method, but many times they word it differently, so I'm going to give you all different terms so you can get used to that it's the same method. Okay? So, our objective for today, I can solve system of linear equations by elimination. Let's read together. 1, 2, 3. I can solve systems of linear equations by elimination. So, in your Ferrer model, you're going to write systems of linear equation. Write that in the center, systems of linear equations. In your Ferrer model, yes?
In a minute.
Okay. Everybody ready?
No. No.
Come on, tomatoes.
I'm sorry. You messed up my counting, Mr. Q.
What?
You messed me up on my counting.
Why?
I'm trying to count, and then you started talking, and then...
Oh.
Yeah. Anna, be nice.
Be nice.
What? I was counting to 12. It was very difficult. What?
You're so much brain power.
Okay, here we go. So, focus please. So in your Ferrer model, it should write system of linear equations. Without looking at your notes, write the definition. Let me get you started. Hopefully it'll trigger your muscle memory. Here it goes. System of linear equations is the set of... Don't say it out loud to yourself. If you don't remember, then start writing an example.
Oh,
with the example, hopefully you should be able to see what you need for the definition. Once you have your example, get a couple of hashtags. See if that triggers something in your noodle. 2 hashtags. If you do come up with the hashtags, then guess what? That's part of the definition. Once you're done with that, get a non-example going. I'll give you 2 minutes. Go. Okay, let's see how close we came to that. Here goes. Definition. It should read the set of 2 or more linear equations that have the same variables. Hands if you got that. Okay, not bad. Now let me show you the rest of it. The whole thing. This is what we did originally. You should have had at least one example that looked like something like this, a non-example that had nothing to do with that, and your hashtags. Something that read 2 or more linear equations or 2 or more equations, something like that, to those words. Same variable, same 2 variables, or whatever you want to word it. Something like that. Okay? So you already have these notes. Today was just to see if you recalled it. Just in case you needed to do that tomorrow by yourself. Just saying. All right, so as promised, now we're in systems, and I'm not going to give you steps, right? But the question you should keep in mind is, how do I solve a system of equations using the elimination method? Right? We came up with 4 steps for substitution. You should be able to come up with 4 steps for elimination. So, underneath your Fourier model, copy this. Example Q. Solve the system by elimination. So set x minus y equals -1, 4x plus y equals 6. Copy that. I'll give you a minute, and then I'll go over this. All right. Writing utensils down. I'm going to go over this. Here it goes again. And just pay attention. Stay focused. Here it goes. Writing utensils down, you're just paying attention. You'll finish copying right now. Here he goes. Talk it over to your neighbor first. Okay, so this method is called what?
Elimination.
Elimination for an obvious reason, right? Okay, so we go from here to here, from here to here, and the rest, I guess the only step that changes in this method is the first step. Is that correct?
Yeah.
Okay, so with that said, copy this next one, example super Q. Notice that I changed the wording. Now instead of saying elimination, it says what?
Combination.
Because it's still the same thing. Is that correct? Yes. It says solve the system by combination, x plus 2y equals negative 1, and negative x plus y equals negative 5. Now, before you begin solving, let me go back to the previous one. Look up. The previous one, I did this. For this one, tell your neighbor where you're going to start. Let's see. I'm sorry? Because this is not a solution. This is just a system. They're indicating that it's a system, but it's not solved. It's just the set of a system. Yeah. All right. So, does everybody know where to start? Okay. See if you can do that one by yourself. Ready? Go. I'll give you Okay. 1 minute. Go. Okay, here we go. So, let me show you the previous one more time. I did this, yada, yada, yada. Then I got the second equation, yada, 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 okay? So, let me go to this one. Here it goes. I'm going to put the plus here to remember what I'm doing. I go here. Hands if you got it to right there. Okay, good. 2y plus 1y is 3y. Negative 1 and negative 5, that's negative 6. Divide by 3. Y equals negative 2. But in this time, instead of getting the second one, I'll just get the first one. That was the purpose of that. It doesn't matter which one you use. That's why on the first one I use the first one, and the second one, now I'm using the first one. Now, look up. From this point forward, since we're going to be doing a lot of substitution, combination, and stuff like that, I want you to write out the equation that you're going to continue substituting in, and I want you to do the substitution of that variable right underneath the variable where you're going to substitute. Because I don't want you to start making mistakes with negative symbols. Here we go. Negative 2. I bring down the x, the plus, the 2. I put that in parentheses because it's the coefficient. Minus 1. X minus 4 equals negative 1. Plus 4 plus 4. X equals 3. Solution, 3, negative 2. Hands if you got that. Okay, good. All right, we got it? Okay, so. Show me with your fingers from 1 to 5, 1 being the lowest, 5 being the highest, how comfortable you feel with these. Okay, I got some 5s, some 4s, some 5s, 4s, 5, 4s. Okay, thank you. All right, let's go to the next one. Here we go. Example mega Q. We got negative 2x plus 2y equals 4, x minus 2y equals negative 7. Copy that, and you should be able to do this one in 45 seconds.
Wait. I didn't copy it down before.
45 seconds. Ready, go. I'll give you some time. Copy that and go. Okay, let's see. Focus. So, on this one, once again, notice that I changed the verbiage, solve the system by addition. So I'm going to put a little plus sign right here. Which ones cancel? Oh, this one eliminates. So we're left with negative 2x plus 1x. That's left with negative 1x equals 4 minus 7. That's negative 3. Divide by negative 1. X equals 3. Does it matter which one I get? No? Who did it with the first one? About the second one? Okay, I'm going to do it with the first one. Negative 2x plus 2y equals 4. And, I'm sorry?
Oh, why is it you said you were
So, what is x? 3. I'm going to write it right underneath. Negative 2 times 3 plus 2y equals 4. Negative 6 plus 2y equals 4. Plus 6 plus 6. 2y equals 10, divided by 2, y equals 5. Solution 3, 5. Hands if you got that. Good. So far so good? How we doing? All right? Okay, let's continue. Here we go. Copy this one. Oh, hold on. Let me go back. Yes. Hold on. Yes. Question. Sure. Let me go over using the second equation. Guys, focus. I'm going to use the second equation. X minus 2y equals negative 7. And what did I specifically say? From this point forward, write your equation and substitute the value right underneath the variable, yes? Or else you're going to make mistakes with the subtraction signs. Here it goes. The x was 3. We're left with negative 2y equals negative 7. Here, some of you made a mistake here because you didn't see this. What operation is here? Multiplication. What is operation here? Addition. Where do we start when we solve? With addition, so therefore subtract 3, subtract 3. We're left with negative 2y equals negative 10, divide by negative 2. Y equals 5. Did we get the same as this one? Yes, it doesn't matter which one you start with. Be careful. Yes? All right. With that said, example super duper Q. Copy this one, please.
Super duper Q?
Yes. Solve the system by elimination. Negative x plus y, negative x equals y plus 4, and the second one is y minus 2x equals 5. Copy it and don't start yet. I'm going to prompt you with some questions so it can get your noodle going so you can know exactly what to do from there. Here it goes. Look up. Here it goes. Look at the previous problems. I'm going to go to the beginning. Look up, please. Look at this. Look at this. Look at this. However, talk it over your neighbor and see if you see what I see. Show of hands if you see it. Okay, Gloria, elaborate for us, please. What is different on this one?
Well, they're not the variables.
The variables are not lined up. Okay. So the only one that we need to line up now is what? So that means I need to take this equation and do what, Gloria? Subtract y, subtract y. We end up with negative y minus x equals 4. I write that here. Negative y minus x equals 4. Do you know what to do from there? Yes, copy that and finish up, please. Go. All right, let's see. Here it goes. I'm going to go over it so that you can still absorb the correct process. Here it goes. So we're here. Okay? I'm going to put a little plus sign here so that I remember that I'm eliminating or adding or combining. We're left with negative 2x and negative 1x. That's negative 3x equals 5 and 4. That's 9. Divide by negative 3. X equals negative 3. Hands if you got that so far. Okay? Next, we take one of the two equations. Doesn't matter which. I'm going to take the bottom one to make a point in regards to substituting with negatives. So I'm going to substitute this one into the second one, which is this one. Does everybody see it? So instead of x, I'm going to substitute negative 3. Bring down the negative y, the negative, which means I need to put this in parentheses, equal to 4. Negative y, and this becomes plus 3 equals 4. Minus 3 minus 3, negative y equals 1. Divide by negative 1. Y equals negative 1. Solution, negative 3, negative 1. Hands if you got that. That is correct. Yeah. Yes? The ones in the warm-up that I explained earlier? And substitution. No. Let's go to the next one. Example, Shazam Q. Copy this one. Shazam Q. Bam. Shazam.
Why is it like an S and a C? Why an S and an A?
No, it's Shazam. My dog's name is Shazam.
That's your dog's name, really?
Yeah. All right. Look at it. It's very similar to the one we just did. Tell your neighbor what to do. I heard somebody say subtract 3y. That is correct. I'm going to take this. Negative x equals 3y minus 8. Subtract 3y. Subtract 3y. I'm going to write negative x minus 3y equals negative 8. And I'm going to write that right underneath. Negative x minus 3y equals negative 8. I'm no longer going to use this top one because I already made it into this. And for the purpose of having you think, because this one we need to think it out. Look up, please. I'm going to cover this up. Look up. Writing utensils down. Here it goes. Stop writing, please. Remember, when you're learning concepts that are a little bit faster than your usual concepts, you really need to focus your full attention on this. Here it goes. Ready? Here it goes. By looking at it, we cannot eliminate anything. Right? Because if we combine these, this is what? Negative 2x. And this is 2y. The only thing that cancels is this, but it becomes 0, but we still have two variables to solve. Therefore, question. What can I do to either one of the equations in order for me to eliminate x? Talk it over to your neighbors, please. What can I do to either one of the equations so that I can eliminate x?
Multiply the second equation by because everything that's in is positive. You can do 2, you can do 3, you can do 4, you can do any number.
Caleb. Guys, Caleb said divide by negative 1 the entire equation. Which equation do you want to divide by negative 1? The bottom one? Okay. How about, could we also, everyone? Multiply times negative 1. Here, let me show you. I'm going to first divide by negative 1. This becomes what? This becomes, and this becomes, are we there? So check this out. If I was to hide this, I'll bring it out right now so that you can copy, but if I was to bring this like this, do you see now that we can eliminate? Now, why did I do it by negative 1? What is the coefficient here on the x? That's why we multiply times that same number. Everybody with me? What if, here goes a follow-up question, look up. What if both of these, or let's say this one of them, this was negative 2x. Negative 2x. What would I divide or multiply this whole thing by? -2 to eliminate the x, because this will be positive 2x that cancels. We end up with a fraction here, but it doesn't matter because we already eliminate one variable. Does that make sense? Copy that and finish up, please. All right, let me just close this. And once again, this top one we don't use because we already transformed this to this one, yes? Okay, so from here, I'm going to do this so you can see what I do. So I won't use this because I made this one into that. But now since I use this one by dividing by 1 or multiplying by -1, I won't use this one anymore. I'm focusing on this one and this one. Are we there? So you can see it from where you're at. I'm focusing on this one and this one. Therefore, we're left with 8y equals 16. 8 plus 8, 16. Divide by 8, y equals 2. I'm going to take one of these two. Which one do you want to use?
Bottom.
Bottom, x plus 3y equals 8. Instead of y, I'm going to write 2. X plus 3 times 2 equals 8. X plus 6 equals 8 minus 6. X equals 2. Solution, 2, 2. Hands, have you got that? Okay, good. All right, so with that said, now we get our steps down. Here we go. Who can get me started with step number 1? Christine.
Eliminate 0 pairs.
Did everybody hear that?
Yeah.
That's step 2. Eliminate 0 pairs. In parentheses, just write variable, because we're eliminating a variable, right? Comma. What else did we do in step 2? Once we eliminated, we combine like terms, yes?
Yeah.
Combine like terms and solve. And solve, okay? Step 1. Jeremiah. Align the variables. Let's be a little bit more specific. Let's see. And let's use some terminology of the forms that we already know that these are called. Tell your neighbor what this is called.
Standard form.
So, what is that form called, everyone?
Standard form.
So what would be our first step?
Put in standard form.
Set in standard form. Step 3. So we set in standard form. Step 2, eliminate a 0 pair, combine like terms, and solved. What is step 3? Hannah?
Solve with a variable.
Yeah, we already solved right here. And solve.
So then substitute the variable.
Substitute the value of the variable into
one of the equations.
one of the equations. And solve. Step 4. Cassandra.
Put it in order pair.
Write possible solution. Cassandra said order pair. What would be our 5th step, everyone? Check. That is correct. Home plate for tonight is on page
300.
300 only. Good one, guys. Enjoy your home play. I'm going to be live during tutoring if you get home and you need to see the last example. See you guys tomorrow. Oh, enjoy your home play. Bye.